Okay, guys, hello. So today, we're going to be going over the quadratic formula and why it works. So here is the quadratic formula itself, and the reason we use this is to find out what the roots are of a parabola. So the root is when y equals 0, and you're trying to find what x is. Okay, so this is the quadratic formula, but I'm going to be showing you how we actually get there. So we start with the standard form of an equation, which is going to be ax squared plus bx plus c equals 0, right? Okay, and then what we're gonna do is get rid of the c on the side, so we can get rid of the constant, and we're gonna get ax squared plus bx equals negative c, right? And now we want to isolate this x squared, so we can divide everything by a, and we're gonna get x squared plus b over a multiplied by x equals negative c over a. Stop. What is it? Okay, so then what we can do is, there's a cool method in quadratics called completing the square. And so what you do for that is, this is a visual proof on how completing the square works. So I'm gonna just make this, circle this in blue, so everything I write in blue will represent x squared. Everything I write in red will be over a multiplied by x, and yellow will be negative c over a. So what we have is a square, the side length of x, so the inside is x squared. And then we have a rectangle with side lengths of x and b over a, right? And so these two added up equals some random shape with the area of negative c over a. So what we can do is, we're going to try to get this into a perfect square trinomial, so that we can get it into like x plus something squared, right? So now what I'm gonna do is actually do the method of completing the square. So I'm gonna cut this up into two parts, so we're gonna get b over 2a, and then one part, let's make this yellow, this part is gonna go here, and this part is gonna go here. So then we're gonna get a new, like, square rectangle-ish thingamajig that's x squared, and then we have this area, little rectangle thing, with b over 2a, and we also have that here, which is b over 2a. So this is equivalent, this weird shape thing, yes, shape thing. Actually I'm gonna add another color here. Let's make this teal, sure. This area is what's gonna make all of this equivalent to negative c over a. And so we are going to know what this area is, and the only reason we can is because b over 2a multiplied by b over 2a is going to give us that area. So we're going to get b squared over 4a squared. Okay? So that means that if we get this into a perfect square trinomial, we're actually going to get this. X squared plus b over ax multiplied by x, plus b squared over 4a squared equals negative c plus b squared over 4a squared. And then, since we do know this is a perfect square trinomial, we know it's actually going to be x plus b over 2a all squared equals negative c over a, I'm sorry, I forgot over a, plus b squared over 4a squared. And now we're going to combine like terms here, and so we need to get them into a common denominator, and that is actually going to be 4a squared, because you can't unsimplify 4a squared. So that means that we can multiply both sides of this by 4a over 4a, which is 1, so you're going to get negative 4ac over 4a squared, plus b squared over 4a squared, and then just, carry this down, x plus b over 2a squared. I'm sorry, my handwriting sucks. Just changed my color here. So now we're gonna get b squared minus 4ac all over 4a squared equals, and this is our important part, right? So we're gonna get x plus b over 2a squared all squared. And so now we need to take the square root, right? So let's take the square root here. Egg. So we can take the square root of both sides, and we're gonna get this. X plus b over 2a is equivalent to the square root plus, or actually the positive or negative square root of b squared minus 4ac all over 4a squared. And so now we need to get rid of this b over 2a. So we can just subtract that from both sides. So minus b over 2a minus b over 2a. And this is pretty much well simplified. Plus, actually, yeah, no. But, no, wait, that is incorrect. Negative b over 2a plus or minus the square root of b squared minus 4ac all over 4a squared. But we can actually simplify this part of it further. So we can get x equals, and then how do we get this here? So what we can do is, okay, wait. So what is the square, when you take the square root of this, that means that you need to find, like, okay, so if I have a over b multiplied by a over b, that's going to be a squared over b squared, right? So when I take the square root of this, we're trying to find, okay, what numerator times itself equals this numerator, and what denominator multiplied by itself equals this, right? So basically we're taking the square root of the denominator and the numerator independently. So what I can say here is that the square root of 4a squared is actually 2a. So what I'm going to do is actually just take the square root of this. So it will now be b squared minus 4ac, and this is going to be r plus or minus, and over 2a. And so now this 2a is not part of what is being like the square root. So we can add this back in. So now if I have negative b over 2a plus or minus this, then if I simplify further, I'm going to get negative b plus or minus b, the square root of b squared minus 4ac all over 2a. And that is why this works. And this is for standard form. Standard form. Standard form. So that's one way, right? If you have oh, what the? It just made my handwriting better, and then it did not care about the S, which is kind of goofy. Anyways, this is S up standard form. So now we're going to find how to do it in vertex form. Wow, so cool. Vertex form. And so vertex form is y equals a multiplied by x minus h squared plus k. And no, we don't need to worry about the b. So what we can do now is get rid of the k. Get rid of the k. And so we know it's going to be negative k. And so it's not y minus k, it's actually negative k because we're solving for the root. So y is going to be 0, right? So 0 minus k is negative k. So that's going to equal a multiplied by x minus h squared. So now get rid of the a. So negative k over a equals x minus h all squared. Take the square root of both sides. So get positive or negative square root of negative k over a equals x minus h. Add h to both sides, and you get this. H plus or minus the square root of negative k over a equals x. I did kind of go through this pretty fast, and I feel like it's just because I elaborated quite a bit here. And so this one should be a lot simpler once you get that. So thanks for watching, and bye.